Hi, today we're going to solve this equation 1 over 2 times the square root of 4x plus 8 equals x. So first, let's start by looking at what makes this equation different from a regular linear equation. So here, the main feature is the square root on the left-hand side. So before we start solving, I want to first review a few basic concepts that are useful for this problem, especially if you have not done algebra in a while. So the first idea is that an equation is like a balance. That is to say, whatever we do to one side, we do to the other side. For example, suppose we start with a simple equation a equals b. This means the left side and the right side are equal. So if I multiply the left side by 2, I also need to multiply the right side by 2. That is 2a equals 2b. The equation is still balanced. In the same way, if I subtract 2 from the left side, I also need to subtract 2 from the right side. That is a minus 2 equals b minus 2. So the key rule is whatever operation we do to one side, we do the same operation to the other side. The second idea is the inverse operations, which is the operations that undo each other. So for example, like multiplication and division, addition and subtraction, squaring and squaring root. For example, multiplying by 1 over 2 is the same as dividing by 2. So if something is multiplied by 1 over 2 or divided by 2, we can undo that by multiplying by 2. And in the same way, if something is inside a square root, we can undo the square root by squaring both sides. The third idea is the square root itself. So the square root of a means the non-negative number whose square is a. For example, the square root of 16 equals 4. This is really important because the square root symbol gives us the non-negative square root. So the square root of 16 is 4, not negative 4, even though both 4 squared and negative 4 squared equals 16. You might be wondering why this matters here. It matters because the left side of our equation has a square root multiplied by 1 over 2. Since the square root is non-negative, the whole left side is also non-negative. That means the right side x must also be non-negative if the equation is true. So because the square root of 4x plus 8 is non-negative, 1 over 2 times the square root of 4x plus 8 is also non-negative. So x should also be non-negative, which means x is greater than or equal to 0. This does not solve the problem yet, but it gives us a clue, right? If we later get a negative answer, we should be suspicious and check it carefully. Now let's move to our problems today. Our equation is 1 over 2 times the square root of 4x plus 8 equals x. So the difficult part is the square root. So our first goal is to isolate the square root. So you may want to know, why do we need to do this for the first step? That's a good question. We are isolating it because we want to square both sides later. If the square root is by itself, squaring is cleaner and less likely to create algebra mistakes in the future steps. So how do we remove the 1 over 2? Since the square root is multiplied by 1 over 2, as we mentioned before, we can multiply both sides by 2. So 2 times 1 over 2 times the square root of 4x plus 8 equals 2 times x. On the left side, 2 and 1 over 2 can cancel out. So we get the square root of 4x plus 8 equals 2x. Now the square root is isolated on the left side. So what's the next step? We need to square both sides, right? Because squaring and square root undo each other. So we square both sides to get the square root of 4x plus 8 squared is equal to 2x squared. On the left side, the square cancels the square root, and we got 4x plus 8. On the right side, we have to be careful, right? Because the square of 2x means the entire expression of 2x is squared. So we square both the 2 and the x to get 2 squared times x squared equals 4x squared. So now our equation becomes 4x plus 8 equals 4x squared. Now we have a quadratic equation, which is an equation with an x squared term. So to solve a quadratic equation, we usually move everything to one side and set the equation equal to 0. So from 4x plus 8 equals 4x squared, we subtract 4x and subtract 8 from both sides. So 0 equals 4x squared minus 4x minus 8. We can see that every term is divisible by 4. So we can first simplify by dividing the whole equation by 4. So we get 0 equals x squared minus x minus 2. Now we have to do the factor. You might be wondering why factors helps. Factoring helps because it allows us to use the zero product property. So what is the zero product property? It says that if a times b equals 0, then we can conclude that a equals 0 or b equals 0. So we want to rewrite x squared minus x minus 2 as two factors. To factor this, we need two numbers that multiply to -2 and add to -1. What are those two numbers? Those are -2 and 1, right? So we can write 0 equals x minus 2 times x plus 1. Now use the zero product property. We can get x minus 2 equals 0 or x plus 1 equals 0. Solving each equation can give us x equals 2 or x equals -1. So now we have two possible answers. But are we really done now? The answer is no, right? Because there is a hint in the problems and ask you to check your work, right? So what and why do we need to check? The reason is that we squared both sides at the beginning, and squaring can change the equation in a way that introduces extra answers. So whenever we solve a square root equation by squaring, we must check our possible answers in the original equation, not in the squared equation. And the original equation here is 1/2 times square root of 4x plus 8 equals x. Let's first check x equals 2. If we substitute 2 into the original equation, we can get 1/2 times square root of 4 times 2 plus 8 equals 2. And simplify that, we can get 1/2 times square root of 8 plus 8 equals 2, which is 1/2 times square root of 16 equals 2. And 1/2 times 4 equals 2. And finally, we can get 2 equals 2. So x equals 2 works, and 2 is a solution for this problem. Now let's check x equals -1. So the step here is just like what is for x equals 2. We substitute -1 into the original equation. 1/2 times square root of 4 times -1 plus 8 equals -1. And simplifies that, we can get 1/2 times -4 plus 8 equals -1. and 1 over 2 times square root of 4 equals -1, and 1 over 2 times 2 equals -1. But this will get 1 equals -1. This is not true, right? So we can know that x equals -1 does not work, and this is not a solution for this problem. This also matches the clue we noticed earlier, right? Since the left side of the original equation is non-negative, so x should not be negative. So it really makes sense that x equals -1 does not work. Therefore, the only solution for these problems is x equals 2. So to summarize the whole process, we used several basic ideas. First, an equation is a balance, so we do the same operation to both sides. Second, inverse operations help us isolate the part we want to work with. Third, because this was a square root equation, we isolated the square root and squared both sides. And then, after squaring, we got a quadratic equation and solved it by factoring. Finally, we checked both possible answers, x equals 2 and x equals -1, because squaring can create extra solutions. So in these problems, x equals 2 works and x equals -1 does not. So the final answer is x equals 2. Okay, so that is the full solution to these problems. Are there any questions about the process? Now I'll move to the speaking portion. I didn't attend Jumpstart as a student last year, but I understand why this period is really important. Jumpstart is not only about reviewing math, it is also a transition into graduate school. Students may come in with very different academic backgrounds. Some students may feel comfortable with algebra, calculus, or statistics, while others may not have used these tools for a while. So I think one of the most important goals of Jumpstart is to help students rebuild that confidence. So as a teaching assistant, I would want students to feel that it is totally okay to ask basic questions. Often, basic questions are actually very important because they reveal where the real confusion is. In my teaching example, I try to demonstrate the kind of approach I would use. I would not just present the final answer. I would help students break the problems into steps, understand why each step is valid, and learn a process they can use again in the future problem. So for me, connecting with students would mean being approachable, patient, and also consistent. So in practice, I would try to connect with students in 3 ways. First, I would try to create a comfortable environment for questions. Some students may hesitate to ask questions because they worry that they should already know the answer. I would try to make it clear that confusion is a normal part of learning, especially during a transition program like Jumpstart. Second, I would use structure when I teach. When students are confused, they often do not just need another explanation, they need a roadmap. For example, in the problem I just solved, the roadmap was first isolate the square root, square both sides and solve quadratic, and then check the answers. I think that kind of structure helps students feel less overwhelmed. Third, I would pay attention to where students are getting stuck. If a student looks confused, I would try to ask a smaller guiding question instead of simply repeating the same explanation. For example, I might ask, what is the operation attached to the square root? Or what operations would undo that? This helps the students participate in the reasoning process. I also have prior teaching and teaching assistant experience. I served as a teaching assistant for several undergrad economic courses, including intermediate microeconomics, public finance, mathematical economics, and also game theory. So, in this role, I basically help students understand lecture material, work through problem sets, review for exams, and think through quantitative concepts step by step. And I was also a part time IELTS English teacher during my undergrad studies. Although that was a different subject area, it also helped me develop important teaching skills. For example, I learned how to explain clearly, adapt to students with different levels of preparation, and support students who may lack confidence. Academically, I bring a strong background in economics and quantitative reasoning. My economics training has required me to work with math, statistics, models, and data analysis. So I feel comfortable helping the students with foundational quantitative material. And personally, I think I bring patience and clarity. I do not expect students to understand something immediately after hearing it once. I will try to break difficult ideas into smaller parts and explain both what we are doing and why we are doing it. For a strength that might also be a weakness is that I am a very detail oriented person. So, as a TA, this is helpful because I am careful about not skipping steps. So, in the teaching problem, for example, I would not simply say square both sides. I would explain why we isolate the square root first, why 2x squared becomes 4x squared, and why we need to check for extra solutions by the problem. But at the same time, I think being detail oriented can sometimes make me spend too much time on one part of a problem. So I have learned that good teaching also requires pacing. Students need careful explanations, but they might also need to see a bigger picture. So I'm trying to balance details with a bigger structure. One challenging academic situation I faced this past year was balancing coursework, research responsibilities, and also professional applications at the same time. I think the most difficult part was that these responsibilities required different kinds of attention. Coursework had regular deadlines and required me to keep up with readings, assignments, and quizzes and exams. Research work was less predictable. I often have to work with complex and messy datasets, and the problems were not always straightforward. And at the same time, professional applications required a different type of preparation because I need to revise my application materials and prepare for interviews. So, to manage this, I first try to break large tasks into smaller and more concrete steps. Once I located the specific issue, the task become much more manageable. And second, I kept more organized notes. This helped me avoid repeating the same mistakes and made it easier to communicate with classmates, professors, and also collaborators. For coursework and applications, I also try to set smaller deadlines for myself instead of waiting until the final deadline. Third, I also learned to ask for feedback earlier because I gradually realized that asking for feedback at the right time can save time and improve the quality of the work. It also helped me become more comfortable with the fact that research is an iterative process. So finally, the outcomes was that I became more organized and more resilient. I was able to keep up with my coursework, continue making progress on my research project, and improve how I present myself in professional settings. And more importantly, I learned how to work through uncertainty without becoming overwhelmed by it. So I think these experiences also shapes how I would support students as a TA. I would try to help students slow down and identify the exact point of confusion. Then we can break the problems into smaller steps and work through it together. I think that is one of the most important lessons I learned from my own academic challenges. When a task feels overwhelming, the best approach is to make it smaller, clearer, and more manageable. Overall, I am interested in the Jumpstart TA role because I enjoy helping students build confidence with quantitative material. I think Jumpstart is an important moment because students are preparing not only for specific math problems, but also for the pace and expectations of graduate school. So, as a TA, I would aim to be clear, patient, organized, and also approachable. I would want students to leave Jumpstart feeling more prepared, more confident, and more comfortable asking questions.